So I want to welcome you all to another EHP event. I am Irene Gesaif. I think you can see my name here. I am an EU projects manager here at the EHPA, and I'll be your host during this online seminar. Today, we have 4 presentations on how we can head towards decarbonization of the industry. I think a topic of utmost importance. 2 of these presentations will introduce 2 Horizon Europe projects, Spirit and Push to Heat, and the other 2 will be presentations by Siemens Energy and the Austrian Institute of Technology. But before we start, just some considerations. The recording and the slides used during this online seminar will be made available to all participants in the next days. So please don't worry, you will be able to recheck the material afterwards and reshare it if you find it interesting. So no problem about it. Then during the event, if you happen to have any questions, again, no problem. You can just write them down on the chat. And during the Q&A session, we can ask them. And of course, if the speaker sees the questions directed to them, they can answer as well. What I kindly ask you to do, though, it's like if you have a question to a speaker, for instance, you have a question for me, you write first the name of the speaker. So in my case, Irene, and then the question. So like this, if I happen to see it in the chat, I can answer directly to you. Then, as I mentioned, we will be presenting 2 projects today, apart from the other presentations. Those projects are Push to Heat and Spirit. Don't worry, you will get to know about them very soon. But if you happen to be interested in learning more about them, there will be 2 newsletters that will be released in April. So if you want to subscribe, I invite you to scan the QR code or even click the link, because I think in this type of presentation, you can actually click the links and subscribe to the newsletter. Then, bear with me, just one more thing. It's finally, if you, I want to ask you, are you involved in any outstanding heat pump projects at the local level? Well, if you'd like to share them with the world and maybe get some recognition, I can invite you to apply to the Heat Pump Award. This edition is the edition of 2023. It's the 13th edition, if I'm not mistaken. We have 5 categories, one of them just for heat pumps in industry. So if you're in, and you can apply now to the Heat Pump Award 2023. And of course, if you have more questions, since this is just a tiny brief introduction, you can direct them to me by email. I left my email there on the slide, so do not worry, and I will be glad to provide you with more information. And now, I think it's time that we actually start with the presentations. So first of all, I would like to introduce you to our first speaker, Andrew Marina. Andrew is the thermal systems researcher at DNO, the Netherlands Organization for Applied Scientific Research. He works in a group of scientists developing and promoting technologies which lead to the sustainable supply and efficient use of heat in industry. The research of Andrew is primarily focused on technical development and implementation of industrial high-temperature heat pumps, and this research is carried out through a multitude of collaborative projects involving end users, technology providers, consultants, and universities. So whenever you're ready, Andrew, the floor is yours. And of course, if you have problems passing the slides, just let me know and I will do it for you. So thank you, and yeah, enjoy.
Thanks, Irina. Thanks for this nice introduction as well. Appreciate it. Well, I don't think I need to give much more introduction after this one, but what I will say is that I've been working at TNO, the Netherlands Organization for Applied Scientific Research, for around 10 years now, and for that time, we've been really promoting the uptake and implementation of heat pumps for industrial applications, and we really wanted to take leadership on this topic over the last years, and for that reason, we're coordinating the Horizon Europe project titled Spirit. So this presentation is intended to give an overview of the Spirit project and talk about some of the goals and objectives that we hope to achieve over the coming years with this project. Just to make clear, I'm not the coordinator of this project, but I'm one of the lead scientists for TNO, and then I'm well placed to say something also about this project. So excuse me, before going into spirits, I just wanted to give some background as to the relevance of heat pumps in an industrial context, and I like to use this slide on industrial energy demand to demonstrate this. And what we see is that around 25% of the final energy consumption in Europe is used in industry. And if we looked at this graph, what we can see is the energy demand industry by end use application, and it's immediately clear that the demand for process heat is dominant. And this process heating is needed at different temperature levels. The majority needed above 500 degrees Celsius, but also significant amounts of low and medium temperature heat are needed in the temperature range of 0 to 200 degrees Celsius. But what you can see is that currently this heat generation is mainly done by non-renewable and fossil sources. So in order to meet the European objectives of 55% reduction in CO2 emissions by 2030 and net zero economy by 2050, we need new ways of generating our industrial heat supply. And heat pumps are well placed to do this. And the reason is there's a multitude of reasons. Firstly, I still see slide 6.
Okay. Yes, you would need to take control. I think there's an option right up for you in the tab, like in the tab above, in which you can take control. If not, don't worry, I can pass the slides.
Okay. I'm so sorry to the audience.
No.
Yeah,
well,
I think we're okay now.
Okay, does it work for you now? I think. If not, don't worry, I'll pass the slides for you.
Yeah, thumbs up from someone that can say it works. Yes. All right.
Yeah, I think it works. Okay,
lots of thumbs up.
Audience.
Great.
That's awesome.
Fantastic. Okay, great. So I'm sorry, but maybe just to briefly run through this. I mentioned that the demand for process heating in industry is dominant, and the heat's needed at different temperature levels, currently supplied by fossil fuel sources predominantly. So we need new sources of for this industrial heat, and heat pumps are well placed for this. So in that case, the reason that heat pumps are well placed for this is because they can transition the industry to uptake renewable electricity, for which we think there'll be prevalent amounts of towards 2050. And they can uptake waste heat, making the supply of heat more circular in the industry. And both these aspects lead to lower energy use and in an ideal scenario, no CO2 emissions. And because of these benefits of industrial heat pumps, well, what we're really seeing is that heat pumps are now being identified as a key technology for decarbonisation of industrial heat supply. So I'll come back on this point on the next slide. But yeah, even though there's all these benefits, there's no silver lining. We can't just take heat pumps and apply them in industry. So what we need is a phased out approach. In the first instance, heat pumps are available at up to 100 degrees Celsius. So we're promoting the deployment up to this temperature level. For higher temperatures up to 200 degrees Celsius, we see there still needs to be further developments to reach these higher temperatures. And we need demonstrations to show this is really a serious technology to cover heat at these temperatures. And finally, up to 500 degrees or above 500 degrees, well, we really see this as a dream scenario for heat pumps, but further research is needed to prove this feasibility. And even if we took these steps, I think there's a lot of challenges to overcome with implementing heat pumps in industry. I mentioned a little bit on the technology availability. We also see aspects related to a limited knowledge base on how these heat pumps can be applied in the process industry, and this affects things like end user confidence in the technology. So we need to get this confidence up, and we also need to tackle things like the economic constraints, the cost of heat pumps, both CapEx and historically OpEx, although this is improving. So I mentioned in the last slide that heat pumps are now identified as being a key technology for decarbonisation of the industrial heat supply. And just to show that this isn't just my opinion, I wanted to provide some references for this. What we see is in the EU Net Zero Industry Act, this is a framework for accelerating the manufacture and uptake of clean technologies, is that heat pumps are identified as a strategic net zero technology. This is along with other technologies such as wind and solar, batteries, electrolyzers. And what that means is there's significant potential for the rapid scale up of the manufacturer to contribute to EU's decarbonisation targets. We can also look towards the IEA, for instance. They recently released a report on the future of heat pumps. In this report, it indicates that heat pumps, which can efficiently supply heat to industry, are the key technology to make heating more secure and sustainable. And also from the IEA, they recently released a report for a net zero roadmap for the global energy sector. And in this net zero roadmap toward 2050, heat pumps were identified to account for 30% of the heat demand in light industries for 2050. And just to give some context of what that means, this would be equivalent to rolling out 500 megawatts of heat pumps every month over the next 30 years. So clearly, there's a lot of potential, and it's exciting times for heat pumps in the industrial sector. The final place where this viewpoint is shared is in the recently released Horizon Europe framework, where we see an increasing number of calls on high temperature and industrial heat pumps. And one of these calls was in 2021, which was titled "Full Scale Demonstration of Heat Upgrade Technologies with Supply Temperatures in the Range of 90 to 160 degrees Celsius." And this is where we submitted the Spirit proposal. The Spirit is meaning implementation of sustainable heat upgrade technologies for industry. And of course, this project was inevitably successful, which was very nice news. And we started working on the project in September 2022, so last year. The project has a duration of 42 months and will continue till 2026. We have 17 partners from 8 countries, and the total budget for the project is 11 million here. I think it's well over that, and with an EU contribution of around 9 million euros. And within Spirit, we have the overarching objective to establish heat pump technology as the reference low carbon technology for industrial heat supply less than 160 degrees in 2030 by carrying out the following sub goals or objectives. So in the first instance, we want to demonstrate 3 full-scale industrial heat pumps in 3 different industrial processes. Now, during the acquisition phase, we really wanted to target sectors where there were repeatable applications for this technology. So we were looking for processes and sectors which had high heat demand in a temperature range less than this 160 or even 200 degrees Celsius. So we will demonstrate this technology in the food and the paper industrial sectors, which meets this requirement. We also see 2 pathways for technology of industrial heat pumps moving forward. That is vapor compression heat pumps for steam generation, and also direct steam compression using mechanical vapor recompression technology. So we will demonstrate both these technologies as part of this project. As a second step, we want to improve the technical and economic performance of high temperature heat pumps to increase their market uptake. Big focus on the technical aspect here, because improving the technical performance also has knock-on effects for the economic performance in the heat pump. So really, we're looking at optimizing the compressor system, the lubrication system, and the overall heat pump system. We also look for opportunities to improve the economics of the heat pumps, which brings me to the third point, is that we really have the ambition in the Spirit project to develop what we're calling the Lego or IKEA heat pump, modular heat pump concept. And this modular heat pump concept means is that we have, for a given heat pump application industry, that we can build a heat pump that matches those requirements based on the limited number of off-shelf components that can be put together like you would a Lego set or IKEA furniture. This repeatable concept also applies to integration of heat pumps in processes. So for processes which we see higher replication potential, we see the highest potential for industrial heat pumps in industry, we'll try to develop standard methods of integration of heat pumps in those processes. And hopefully this not only works to reduce the costs, but also to accelerate the rollout of this technology into the future. As a fourth point, well, yeah, what we really see is that one of the challenges for industrial heat pumps is the business case, and specifically that you have a high investment cost which needs to be borne by the end user at the start of the project, and this can hinder the uptake. So what we're looking at is, for instance, innovative business models for upgrading heat. These innovative business models can include, but are not limited to things like leasing agreements, looking at heat as a service, or heat upgrade in multi-stakeholder environments where you have, let's say, multiple utility providers and or multiple end users. And as part of this, we try to identify the possible regulatory barriers that could be in place for these business models and how we can overcome these. And as a final point, it's really our ambition as part of Spirit to take the learnings that we have from this project and disseminate it to a wider audience. So we really want to say not just what the benefits of industrial heat pumps are, but we also want to sort of identify or inventorize what the challenges are for heat upgrade technologies and how we can overcome these. So I think that's a really important part as well. In terms of the consortium that will work on these objectives, what we've tried to do is incorporate all sort of areas of the value chain. So what you can see here is in the first instance, we have technology suppliers. For instance, we have the heat pump manufacturers such as Spilling, Maekawa, and Gaia. We also have TVP Solar involved in the project, which manufactures vacuum plate solar collectors. So we want to see about the ability to incorporate solar thermal heat combined with heat pumps into the process industries. We have 3 end users involved in the project, namely Smurfit Kappa, Stella Polaris, and Tiensa Sauka, where the heat pumps will be demonstrated. We also have a number of knowledge providers, which will support, let's say, the manufacturers and the end users in this. For instance, we have TNO, DTI, and DLR, which are heavily involved in the demonstrations, but also in technical developments. We have Danish Technical University, which will be involved in looking for the replication potential for this technology in the district heating sector, and TLK Energy, which will develop integration and heat pump design tool chains, which will be available to the public, which take, let's say, a lot of the learnings of Spirit and incorporate it into those design and integration aspects. We also have parties on the business support aspect. Synlock will develop the innovative business models, as was discussed in a previous slide, and we'll have Eurek Research conducting a market study for industrial heat pumps under different scenarios and seeing how that market will evolve, let's say, under different scenarios moving towards 2050. And hopefully these parties generate enough content and information that we like to disseminate to the wider audience. So we have dissemination partners, the main one being the European Heat Pump Association, which I think needs no introduction. And we also have Euroheat and Power, who can disseminate the messages to the district heating networks or parties in the district heating sector. We are supported and steered by an advisory board. You can see the parties which are involved there. This advisory board also has branch organizations involved, which I think is really important to as well spread the message of the Spirit project. And just to sort of like finalize or finish off the presentation, I think the largest, the most interesting part of the Spirit project is indeed the demonstration sites. So I wanted to say a little bit more about each of the demonstrations that we plan to where we plan to showcase this innovative technology. What we can see is for each of the demonstrations, we have an end user from the process industry, we have a technology supplier, and we have a knowledge organization which is supporting in aspects such as integration and also the measurement program and analysis of results. The first demonstration project is at the location of Stella Polaris, which is in Tromsø, Norway. I'm not expecting you to know where Tromsø is, but this is really at the very north of the country. This is a nice sort of image that we have of or an aerial shot of a part of their production facility. And at this production facility, they're cooking, peeling, freezing, and packaging cold water prawns. The largest user of heat on the site is the prawn cooker. And what we'd like to do as part of this project is we'd like to generate steam, 4-bar steam for cooking up these prawns. And as a waste heat source, we plan to use condenser heat from the existing freezer plant, which is on site. One of the challenges here is that the freezing plant projects heat at around 21 degrees Celsius, which means we have to have a large temperature lift in the order of around 125 degrees Celsius. This leads to a relatively low COP, but nonetheless still has good prospects from a business case, energy and CO2 saving perspective. In order to achieve this large temperature lift, we will use vapor compression heat pump technology from Maekawa. We will have to use a cascade system in order to achieve this, where we'll have a bottom cycle consisting of a piston compressor and ammonia. This is technology which is currently available but from Maekawa. And we have a top cycle, which is really where the innovative part of the process is. And in that case, we will produce the steam at 145 degrees Celsius. And in this case, we'll use a screw compressor and pentane as the working medium. For the excuse me, for the second demonstration site, this will be at Tiensauke, which is located in Tienen in Belgium. As you probably guessed, at Tiensauke, they're producing sugar. There's a number of steps in the production of this sugar, from extracting the sugar from the beet and then filtering and concentrating this juice, which results from that before crystallization of the sugar. We're focusing on the concentration of the juice, which is done through evaporation of the water. And this is done in multi-effect evaporators, where we input steam at a high temperature, and we have multiple stages where the steam pressure and temperature is reducing for each subsequent stage. And at the end of this process, we have a vacuum steam which is available from the multi-effect evaporator, and we plan to upgrade this in temperature from around 76 degrees up to 138 degrees to produce the 3.4 bar steam that can be reused in the process. For this process, in order to have this temperature lift, we'll use vapor compression heat pump technology from Gaia. Again, we'll use hydrocarbon pentane combined with the screw compressor. One of the main challenges that we have with this site is that we have a latent heat stream, which is in the form of vacuum steam on the low temperature side of the heat pump. And that means we have large volumes, and we need to have very big heat exchangers in order not to have too high pressure drops and temperature drops on the source heat side. You can see from the duties that's presented here that this is by far the largest demonstration that we'll do as part of Spirit, and I think it's significant that we go up to 3.5 megawatts here. And the final demonstration, which will be at Smurfit Kappa, location Morava in the Czech Republic. At this location, Smurfit Kappa is producing corrugated paper, and this is done where we have a web of wet paper, which is essentially pressed, and then it's dried by rolling this over cylinders which are filled with steam. So the steam, which is used for drying of the paper, this is the largest energy consumer in the process. And after the steam goes through these cylinders, it's condensed, and it can be used as a source of heat for the heat pump in that case. So we will flash the condensate to produce steam at 2 bar, and we'll upgrade this in temperature level to produce 6 bar steam, which can be reused for drying off the paper. The technology to do this will be a piston compressor system from Spilling Technologies, and what the nice aspect of this is that really it fits with the Spirit modular concept, in that we will have a containerized heat pump unit, which is modular in nature for easy plug and play. I hope this is giving a nice introduction to the Spirit project in a public forum. If you're really interested, you can follow us on social media, and of course, you can drop your questions in the chats that I'll answer later, I think. And if you have other burning questions that come up in the coming weeks and months, you can get in contact with us through info@spirit-heat.eu. Thanks very much.
Thank you very much, Andrew, for your presentation. And yes, indeed, we will answer some of the questions afterwards in the Q&A. But in a way, I think we have like a couple of questions that we could actually answer now, because I think two of our audience members were asking whether there was a way to support the project in any way, shape, or form. So I think you could address this now.
yeah, I think there's definitely some ways that we can look for support in this project. For instance, I think it would be one of the aspects that we'd like to look into is tackling or to sort of identify the challenges for industrial heat pumps in industry and look to ways which we can overcome these challenges. So we're looking for like input, let's say, from all areas of the value chain about the perception of the technology, what challenges people faced, what their experiences are, and hopefully this can be used to let's say that we can overcome these and further the technology. I think that's probably the main way. Yeah.
Thank you for that. And then I want to remind the audience members that if they have a question, of course, they can add it in the chat. I see that you're doing it, but to please indicate like the name of the speaker, because right now just Andrew spoke. However, afterwards it can be a bit confusing. But yeah, thanks for being that active as an audience. So I think it's time that we move on to the next presentation. I would like to ask Maider to see if she can connect correctly and speak. Let's see. Does this work for you, Maider? Can you speak?
Yeah.
Oh,
Hello.
yes.
Okay,
Amazing.
it works.
I will introduce you then. Just for the audience members to know, we were experiencing some little problems, but now it's working. So very happy to have you here, Maider. So, well, I would like to introduce you all to Maider Epelde. Maider is working at Tecnalia since 2007. She has more than 15 years of experience in the field of low carbon heating and cooling systems for buildings and industries. She's an industrial engineer specialized in energy technologies and has a master's degree in air conditioning technologies and energy efficiency in buildings. She is involved as a senior researcher in several R&D projects related to heat pumps and energy storage. And finally, now she's working as a project manager in renewable energies and in the thermal efficiency area. So Maider, you can take control of your presentation, but if it doesn't work for you, don't worry, I can pass the slides. So just let me know.
Okay, let's try. I think it should work now.
Yes, I think you're taking control. So yeah, it's your time to shine.
Okay, so thank you, Irene, for your introduction. So, well, as said, my name is Maider Epelde, and let's say I work at Tecnalia. It's a research institute in Spain. And yeah, I am the project coordinator of the Push2Heat project. So yeah, my idea today is to give you an overview of this project. So that you can have a better idea of what can be expected as outcomes or results from the next months and years from this project. Because, well, we have this project started just some months ago, in concrete in October last year. So we are still, and it has a duration of 4 years. So we are, let's say, still in the initial stage of the project. So we don't have many results yet, but the idea is to give you an overview, more or less as Andrew has done. So just to say as well that Push2Heat is the, let's say, the sister project of Spirit. Both projects were funded in the same call by the European Commission. And yeah, so let's say dealing with more or less the same in the same field. Okay, I will start very briefly, just with a short introduction, talking a little bit about the context. I will not extend a lot on this. Andrew has talked also a little bit on this, and well, probably all of us, everyone that is today here in this event knows what we are talking about. So, I mean, in general terms, you know, we are talking about decarbonization, this huge challenge that we are facing. Very important, necessary, and of course very urgent. So industry playing a key role due to its high portion of CO2 emissions coming from industry, and yeah, as well as Andrew has said, I mean, high temperature heat pumps can be a key. One of the, together, of course, together to other technologies, other energy interventions and other energy actions, it can play. It can be one of the technologies, key enabling technologies towards the achievement of these decarbonization objectives. So, well, not much to say here. Andrew has said it already. So we are talking about using a technology that can make use of some heat sources that otherwise are wasted. So, and just to produce heat that can be used in the process, in the processes, industrial processes, just reducing the energy consumption from fossil fuels. And as well, maybe just to add something else, well, I think we are talking about a cross-sectoral technology. Yeah, we are not just improving the energy efficiency, but as well, at least when talking about electricity-driven heat pumps, it helps to use more sustainable, greener electricity. So yeah. Well, probably we all know about the main benefits that are linked to these technologies. So I'm not going to extend much on this, and just a couple of figures before going more into details about the push-to-heat project. So from one hand, talking about the process heat, around 37% of the process heat that is required by all the industry in Europe is below 200 degrees centigrade. So, I mean, we have a lot to do here. So, well, depending on the output temperature, the maturity level for high temperature heat pumps is not the same. I mean, it's not the same if we are talking about delivering heat at 120 degrees centigrade or delivering heat at 200 degrees centigrade. So the maturity level is different, but there is a kind of agreement that the heat pumps can be a powerful, strong technology to tackle this process heat up to 200 degrees centigrade, more or less. So, and we see that the market potential or the amount of process heat that we can reach through heat pumps is really high. And on the other hand, regarding available waste heat, it's not easy to estimate this, but there are some studies doing some estimating this available waste heat in the industry. In fact, they have taken this study that comes from TNO, and they estimate that is around more than 200 terawatt hour between waste heat between 40 and 100 degrees centigrade. So heat pumps are like a perfect match between these. We have a lot of waste heat available. We have to decarbonize the thermal processes. So let's do it. But the truth is as well that the potential seems to be high, but still the actual market is not too high. Let's say that it's emerging, and probably most of you, many people that are today here in this event probably knows better than us that there has been like a change in the trend, market trend in the last couple of years. It seems heat pumps are really the interest from end users and from the, let's say, different companies in the value chain is increasing a lot. So it seems, well, there is a change. But still, the truth is that the actual market is not so high, but the potential is there and the need as well. So I would say this is a little bit like the starting picture for the push-to-heat project, and it was conceived based more or less in this framework. Yeah. So I'm going now to focus a little bit more on the project itself. So I have make a kind of a very I have summarized a lot the objectives of the project, and I would say we have like two main pillars. It's of course it's we are talking about technology, so it's a technological project, but not only. So we are talking about we are considering 4 different heat upgrade technologies. I will talk a little bit later or more on this later. So we are talking about improving the technologies. Of course, we are not developing new technologies, but we are talking about optimization, upscaling, further improvement, or whatever. But is not, as said, it's not just a scientific or technological project. We have also we want to tackle very clearly market and business related objectives as well. So the idea is to push forward the market potential, this market potential that I have just mentioned, that is in principle is high. Working on new business models and any action towards to help these technologies to deploy in the market in the next years. So let's say that these are the two main pillars of the project, but at the end of the day, we are talking about, or based on these pillars, but we are talking, the core activity will be the demonstration of 4 full-scale pilot plants in different industrial applications. And in summary, the main features are these ones that we see here. Regarding waste heat, we are using waste heat from 40 to 90 degrees centigrade. Regarding the heat supply, we are talking about delivering heat at between 100 and 140 degrees centigrade. And regarding the system size, we have demo sites starting from around 500 kilowatts of delivered heat up to around 3 megawatts. Okay, so this, let's say, a big, like an overview of the main objectives. And regarding the technologies, the involved technologies in the project, as said, we are considering for different technologies that will be provided by four manufacturers, and we are considering electrically driven heat pumps, but also thermally driven heat pumps. In electrically driven heat pumps, we have on one hand, well, these are the vapor compression cycles. So we have from one hand the manufacturer SPH from Germany, who will provide a vapor compression heat pump with a piston compressor. And on the other hand, we have also Enertime from France, working that will provide vapor compression heat pumps with turbo compressor, so for larger scale. And in thermally driven heat pumps as well, we are considering 2 different technologies. From one hand, absorption heat transformer with water lithium bromide as working fluid by BS Nova from Germany, and also a thermochemical heat transformer by Q-Pinch from Belgium. Yeah, and this is an overview of the technologies that are involved and will be demonstrated in the project. Okay, and then regarding the demo sites, we have 4 technologies, and we have 4 demo sites, 1 demo site for each technology. Okay, so the first one, or one of them, is will be implemented in a paper industry in Germany, in the city of Weissenborn, and the plant owner is Felix Scholler Group. And here the idea is, well, the technology by, or the heat pump by SPH will be the one that will be demonstrated here. And the idea is, as waste heat source, heat is coming from will be an exhaust heat from the paper machine dryer. So they have a glycol circuit already implemented from the exhaust humid air heat recovery circuit, and they are using this heat they were already using this heat for space heating, but still they have more waste heat available. So the idea is to use this waste heat to activate this heat pump to produce low pressure steam at 1.8 to 2.2 bar approximately. So here we are talking about quite important temperature lift, probably not so high as one of the demo sites that has been explained by Andrew and is part of Spirit. But here we are talking also about a temperature lift of 80 Kelvin more or less. So, and of course, this is translated into the COP as well, but it's expected to have quite interesting COP. Here, well, as you know, we are still in the initial stages of the project, so we are still doing the first assessment, well, energy system concept and so on. So the accurate results will come later on, but we expect a COP around 2.3, 2.6, more or less. And regarding the size, we are talking about a high temperature heat pump unit of about 840 kilowatts of delivered heat. Okay, we have another demo site. This one will be implemented in the city of Lazio in Italy, close to Rome, and in concrete in the plant owned by Quartiere di Guarcino, also paper industry. And here, the heat pump of around 2.8 megawatts will be implemented, provided by Enertime. And in this case, well, it's a paper industry, but we are not, let's say, taking or integrating it in a process. But the waste, yeah, we are integrating it, of course, in the processes. But what I wanted to say is that the waste heat is coming from cooling water of the CHP plant, of the cogeneration unit that they have to deliver the electricity and steam that they use. Yeah, so I mean, it's a paper industry, but this can be replicated a lot in many other industries. So yeah, they have a lot of waste heat available. So the idea here is to use around 2 megawatts of this waste heat at 89, 90 degrees centigrade, more or less. Yes, cooling water. And yeah, this will be used to activate the heat pump, and the heat pump will produce a low pressure steam. Here still we are defining the let's say the concept for the energy system regarding how will be used this steam that is produced. So well, so far the idea is that to produce part of the heat will be produced at 1.8 bar of steam, and another part at 3.6 bar. But as well, we are still this concept is not closed yet. We are working on checking which is the best solution for the integration of the heat pump in the heat processes. So one option is the use of a thermocompressor to at the end deliver a higher pressure steam to introduce it directly in the low pressure line of the processes. But another option is to what the project partners, I'm not personally involved in this, but the project partners, what they are working is to also trying to identify specific processes that could use this lower pressure steam directly, which would, of course, increase the overall efficiency of the system. So, but as well, we are still working on this. And yeah, let's see in the upcoming months, which is the final solution. And here the expected COP is around 3.6, which is a very interesting COP. Yeah, this is, let's say, an overview of this demo site. Okay. The third one will be located in the city of Santander in the north of Spain. It will be implemented in a chemical industry in concrete owned by the company Dinasol. And here the technology that will be demonstrated is an absorption heat transformer by BS Nova. And the waste heat, here again, we are still checking different alternatives, and it's not fully clear where where the pilot plant will be located, because there are very two waste heat sources that are very interesting to be used. So let's see that in the next months will be decided. But well, the idea is to use a heat source, a waste heat source that is in the range of 89, 90 degrees centigrade. It will be a condensate condensing. It will be a heat from condensation process. So yeah, taking this heat, this will be around 1 megawatt of waste heat at around 89 degrees centigrade. This will be used to activate the absorption heat transformer, and yeah, we will get as an output around 500 kilowatts of heat. Depending on where at the end is decided to implement the this heat pump, the delivered heat will be used to preheat the chemical product up to 130 degrees centigrade, or can be used also to produce to generate a steam and introduce it in the process. Yeah, that's the idea. And well, just to say here, this is a different heat pump from the ones that I have mentioned for the other two demo sites. So we are talking about a thermally driven heat pump. So as you see, this means it doesn't have a compressor, so we don't have, let's say, such amount of electricity consumption than during operation, but we need to consume around 1 megawatt of waste heat to produce around more or less half of the heat at a higher temperature level. Okay, and the fourth one, or well, not the last one, but yeah, the demo site link to the thermochemical heat transformer. This will be a little bit different, also because the story behind the technology is different, and I will talk on this a little bit now. This will be the tests for this technology will be done in a R&D plant owned by Q-Pinch. Q-Pinch is in fact the manufacturer of the thermochemical heat transformer. So yeah, they have these facilities, and the test, as said, will be done there. So here the story, as said, is different. Well, the story is that this thermochemical heat transformer is commercially available, but in principle is more suitable for higher temperature levels than the ones that we are considering in the push-to-heat project. So let's say that there are already some installations available all around the world that can take waste heat above more than 100 degrees centigrade up to well, above 100 degrees centigrade, and deliver heat up to, I mean, above 150, up to 200, or even higher. So this is let's say the most common place for this technology. But the challenge related to, and the objective related to this technology in push-to-heat is to adapt it so that it can be it can work not just from technical point of view, but mainly from making it successful also from economic point of view. So to adapt this technology to lower temperature ranges. Yeah. So this is what we will do in the project regarding this technology. So to adapt it so that it can be also appropriate for waste heat sources between 60 and 90 degrees centigrade, and process heat delivery either as hot water or steam, but more or less in the range of 110, 150 degrees centigrade. Okay, just to finish, I mean, this has been an overview of the project, the demo sites as main activities, and just I would like to mention a couple of issues before, let's say, before saying thank you or goodbye. So from one hand, I would like to say something about replication studies. So within the push-to-heat project, we are going to do this, what we call it, replication studies. So it means that we'll do, I mean, the project partners will do some techno-economic feasibility assessment. What we want to focus on the technologies of the push-to-heat project. So what we want to do is to do this analysis into real cases, not just under generic boundary conditions, but under real cases, real processes, real boundary conditions. So, if any of you would be interested in doing these replication studies in your plans, in your processes, we would be more than happy to have you on board for this. So let's say that of course we would need some input data to do these studies and so on, but then the assessment, the study would be for free from project partners to the interested ones. So in case any of you could be interested on exploring this opportunity, please contact me, and without any commitment, let's talk about it. Also, in more general terms, in case any of you or not that you haven't done it yet, or you are, or it's the first time you are listening about the Push to Hit project, and you are interested in receiving periodic information on the progress of the project, please let me know or fill in the following link. And automatically you will receive some periodic information, some newsletter, just talking about the events we organized, about the progress of the project and so on. Let's say some dissemination material that we develop, so you will receive it. So this also something that I wanted to mention. And just to finish, last but not least, I wanted to say that, we are open to hear you. What I mean with this is any input, recommendation, experiences, positive or either negative as well. Any needs or barriers or experiences that you have had in this field will be very valuable for us. Not just to learn about it, but to steer the project in the good direction, and also because we want to generate interesting results for anyone working in this value chain, in the whole value chain of industrial heat pumps in the market. So we are I haven't mentioned it, but we are 17 partners in the project from different profiles. Scientific and research partners, manufacturers and users, engineering companies, also European Heat Pump Association, dealing with dissemination activities. So let's say we are a group of 17 partners working all together, joining forces, and if we can have any input from the, let's say, external audience that is also working on this field, will be very valuable for us. So we will be more than happy to hear you and to receive any input on this field. So I wanted to say it as well. And with this, I finish my presentation. So thank you in advance for joining us this event today. And if you have any question, of course, I will try to answer you.
So thank you very much, Maider, for your presentation. Actually, I had a question for you, but you answered it with your last slide, because I was going to ask you how can people support the Push to Hit project. So again, if you're interested in taking part on these replication studies, you can email Maider. And as I said, the slides will be available in a few days. So of course, you will be able to have her email. But thank you very much for that. And I want to remind all the speakers that to check also the chat, because I think there are some questions that are directed to you. So maybe you can start answering, and some of them we will save them for the Q&A, of course. But I think some of them are little things that you can provide the answer to. But now it's time that we move on to the next presentation. So I would really like to introduce now to Jochen Schäfer. Jochen, if I pronounce your name wrong, I'm so sorry.
No, you did it really good. Thanks a lot.
Oh, great. Thank you. So Jochen is currently the head of high temperature heat pumps at Siemens Energy. He is responsible for the market introduction and advancement of this new product line. Before, Jochen was heading a team of specialists optimizing energy systems for specific customer sites with respect to techno-economics. And prior to the spin-off of Siemens Energy, Jochen was working for Siemens Corporate Technology in different research and managerial positions, amongst others, senior key expert for thermal energy conversion storage and head of research group distributed energy systems and heat conversion. Jochen Schäfer studied energy and process engineering at the Technical University of Berlin and chemical engineering at the Illinois Institute of Technology in Chicago. Subsequently, he pursued a PhD in energy and process engineering from the Friedrich Alexander University Erlangen-Nuremberg. So, Jochen, whenever you're ready, you can take control of your slide just up there. And if it doesn't work for you, let me know and I'll pass the slides for you. But the floor is yours now.
So first of all, thanks for the kind introduction and thank you for giving me the opportunity to give a short presentation on our heat pump portfolio and let's say a nice combination to my mind of high temperature heat pumps and steam compression. So here, unfortunately, Irene, I cannot change the slide.
No problem. Then just let me know when I should pass the slides and I will do it for you. Oh, it works.
Now
I think
it
you took
works.
control.
Yeah, so
oh, okay, amazing. It sometimes takes a couple of seconds, so I let you do your presentation.
Okay, thanks a lot. So let's say first of all, let's shortly recap why we talk about heat pumps that intense in the last months and years. Yeah, it is first of all if you want to think decarbonization for the entire energy system, yeah, you really have to take into consideration that 50% of the global final energy consumption is in heat. Yeah, so only 17% in electricity. So heat is by far the most important, let's say, sector. Moreover, we have to take into consideration that about 76% of this heat is today from non-renewable sources, resulting in the fact that about 40% of the global energy-related carbon emissions are caused by heat supply. There are many studies out there and analysis by, let's say, energy system researchers looking for a smart way out of this situation. Yeah, and one is use of renewable heat is a key. Yeah, due to the analyzed by the International Energy Agency, and there are basically two ways to do so. One is the use of modern biomass, yeah, which is something like a industry-specific and country-specific phenomenon. Yeah, it's the fiber industries and related sectors, especially in India and Brazil. There's one more option, yeah, which is the use of renewable electricity for heat generation, and this is something that can be done globally, and this should be the focus of my presentation. So first of all, if we talk about using electricity for heat generation, then it's important that we agree on the means of efficiency. So if we want to measure this efficiency, there's a so-called coefficient of performance, which is the ratio of thermal energy at the useful temperature level over the electrical energy that we have to basically invest to get this thermal energy. Let's say in the public discussion, yeah, there are basically three options that are discussed for the future. One, let's call it the reference option. Yeah, it's the electrical heater. Yeah, and there it is a direct conversion of electricity to heat, and the coefficient of performance is about 1. There is, let's say, also a discussion of using, let's say, hydrogen for heating purposes, or even, let's say, power to X products, yeah, like a synthetic methane or something like this for heating purposes. There we have to bear in mind that the coefficient of performance will be smaller than 0.75, yeah, because we have to incorporate the energy or the efficiency factor of the electrolyzer, and after that then we can burn this new product, and let's say the efficiency in this term is rather poor. Let's say the smart way or the energy efficient way of using electricity for heating purposes is that we use heat pumps. Yeah, in heat pumps, We use the electricity to basically pump heat from a lower temperature level to a higher temperature level, and that's why the coefficient of performance can be between 2 and 6, for instance. And let's say this is in good agreement with the principles of thermodynamics, yeah, because it's really only the electricity is driving energy, so driving, for instance, vapor compression heat pump, and here you can basically see the sketch. Yeah, so I think heat pumps in general is not a too modern technology. It's available in refrigerants, in households, and yeah. So what is Siemens Energy doing about it? And to illustrate this, I brought a little sketch. You can see on the y-axis like the temperature level, and on the x-axis is the thermal power. And let's say basically we as Siemens Energy we start in the single megawatt power range, yeah, going up to 70 megawatts per single unit. And with our so-called low temperature heat pump portfolio, we go up to 100 degrees C, and with a high temperature portfolio, we go up to 150 degrees C. Moreover, yeah, we have an in-house portfolio for steam compressors, and using the steam compressors, we can then further increase temperature and pressure to about 55 bars and 270 degrees C. So in summary, yeah, we start at about 7 megawatt. We can go up to 70 megawatt with a single unit. We can go up to 150 degrees C with our regular, let's say, high temperature heat pumps. We selected the working fluid in a way that it has a low global warming potential and let's say zero ozone depletion potential, or almost zero. We know that there is, let's say, a critical discussion on synthetic refrigerants, yeah, and we as Siemens Energy clearly commit to sustainable business, and we will offer heat pumps based on, let's say, natural refrigerants as an alternative. However, we see that especially with respect to, let's say, safety properties, the synthetic refrigerants have been developed, yeah, that they have, for instance, no flammability and lower toxicity, and this is something that is for an application very nice. Well, we have the option to drive this heat pumps with for sure with an electrical drive, but in some special industrial applications, we also think about mechanical drives. So using a steam turbine to drive the heat pump compressor, we have this option to increase pressure and temperature for in industrial applications, yeah, to 55 bars and 270 degrees C. Yeah, and we would be willing to do something like a component supply, which was something like a heat pump island, perhaps, yeah, up to a full turnkey if the application is large enough to our mind. Well, yeah, and we do this development and we market it basically for two large market segments. On the one hand, we have the process industries, and on the other hand, we have the continental district heating systems with forwarding temperatures that are, let's say, higher than 100 degrees C in winter times. But I promised to give you some more details on heat pumps plus subsequent steam compression, and there I prepared some slides showing a case in chemical industries. So let's have a look. First of all, here on the left-hand side, you can see this is basically the high temperature heat pump cycle. Yeah, we take some waste heat, for instance, let's say cooling water coming back from a chemical reactor, or some, let's say, cooling water that is let's say from an entire site, so primarily going to a cooling tower. Let's say we have it, yeah, and we cool it down, and afterwards we can, for instance, do some feed water preheating. We do it whenever there is this option. We have the, let's say, high temperature heat pump cycle in here, yeah, and we produce low pressure steam, something like whatever 1.5 bar. steam, and then we have a subsequent steam compression. We do this if needed in the multi-stage arrangement, and we can also do intercooling. Yeah, and finally we can really, by the last spraying of water, we can really adjust the steam parameters to the parameters that are needed by the customers. And let's say an arrangement such as this has, let's say, significant advantages. Yeah, first of all, we can reduce the overall efficiency and therefore reduce the primary energy uptake. We can use electricity as main driving energy instead of fossil fuel. Doing so, we can reduce the CO2 emissions, and yeah, we reduce the dependence on fossil fuels, which is an additional, let's say, nice feature, let's say, in this geopolitical situation that we have so far. Well, and then there's some technical aspect that I would like to emphasize is, for sure, there is a certain range of pressure levels that we can achieve using the high temperature heat pump only. Yeah, it's sketched like here. So here is the pressure level and here's a coefficient of performance. And if we do so, we have, let's say, a rather steep decrease of the coefficient of performance with, let's say, pressure level out. Yeah, and there is a certain overlap ratio, as I mentioned. Yeah, we can produce here 1.5 bars, for instance, and then we can have a subsequent steam compression. And let's say doing so, you can see here, this is the line with the steam compression. There's also an advantage, let's say, with respect to the coefficient of performance. Doing so, which can be interesting. So in a certain part, yeah, we can take the decision based, for instance, on techno-economics. Is it better to have, let's say, only the high temperature heat pump? Or is it better to have the combination of a high temperature heat pump plus a steam compressor? Yeah, let me summarize my point. First of all, the electrification of the heating sector is key to meeting global emission targets or emission reduction targets. Heat pumps allow for energy efficient decarbonization of the heating sector. High temperature heat pumps facilitate low carbon heat supply to district heating systems and process industries, and the subsequent steam compression opens up new possibilities for steam supply up to 55 bars and 270 degrees C. Siemens Energy has, for the low temperature heat pump, let's say, a significant track record. And we have advanced products for heat supply at higher temperatures. And yeah, we would like to be your one-stop shop here, starting with initial assessment of your heat sinks and sources, for instance, going up to, let's say, a heat pump plant that is ready for low carbon operation. So that's what I wanted to tell you, and I'm looking forward to answering your questions. Thank you.
Thank you very much, Jochen, for your presentation. I'm sure there might be already a couple of questions in the chat for you, but we can address them as well in the Q&A if they're too long to answer on a little text. So I would suggest that to move on to the last presentation of today. Just give me a second. I will just go here. Yeah. Okay, this works. So I would like to introduce you to our last speaker of the day, the last but not the least, obviously, and that is Veronika Wilk. Veronika Wilk is the Senior Research Engineer and Thematic Coordinator at the Center for Energy at the Austrian Institute of Technology. She leads the research field efficiency in industrial processes and systems and works in national and international research projects energy efficiency and the integration of heat pumps. She coordinates demonstration projects for high temperature heat pumps, and she holds a master's degree and a PhD in chemical engineering from the Vienna University of Technology since 2013. Veronika is the author of various scientific publications and has received several awards for her work. So Veronika, whenever you're ready, the floor is yours. And
Thank
if
you
you
very
can,
much.
of course, if you can take control of the slides, amazing. If not, let me know and I'll pass the slides myself.
Yeah,
So-
I will try. So let's see. Yeah, I think it works.
Okay, it works.
Perfect.
Okay, lovely. So the floor is
Thank
yours
you.
now.
Thank you very much for this kind introduction, and also thank you for the invitation. It's a great pleasure to be part of this webinar. And in the next couple of minutes, I will give you an overview on the research activities of AIT in the field of high temperature heat pumps. Couple of words on AIT. We are Austria's largest RTO, and we are working in the field of infrastructure systems and all the topics that are relevant to shape our future. So we are active in different fields, but for today, most important are our activities in the energy sector. And here we are focusing on thermal energy for industrial systems. And we are doing research on high temperature heat pumps for more than 10 years now. And I have listed here a couple of challenges that are also already discussed in the chat. So these are really, really important topics. So first of all, it's about the selection of the right refrigerant. This is a debate that is getting speed at the time of speaking, but it's also about temperature resistant materials and components. And then we have a lot of questions to sort concerning the right integration into the industrial process. So first of all, we need a suitable heat source, possibly also a heat source with a high temperature, but a heat source that cannot be used otherwise in the process, also to do the integration in a thermodynamic correct way. And another important item in this research is the question of efficient cycles. So it's not only about producing the high temperature heat, but also do it in the most efficient way. And there are very interesting approaches also concerning pressure recovery that could lead to more efficient cycles here. On the other hand, for this type of development, we also have the requirements of the industrial applications. So first of all, process integration to get to an efficient result, but also high availability and reliability. And the last point that is mentioned here is probably at the time of speaking the most important one. It's also about security of supply and economic viable solutions. First of all, I'd like to introduce you to the Dry Efficiency Project. This is our flagship project in the field of high temperature heat pumps, where we demonstrated high temperature heat pumps that were able to reach 160 degrees. So this project was really focusing on component development and demonstrating the heat pumps in a real environment. You see here the very shortest summary that's possible of the project. Those are the demonstrators that have been built and operated. So we had 2 demo sites in Austria, one for brick drying at Wienerberger and another one for starch drying located at a production site of Agrana close to Vienna. And the third heat pump that was demonstrated in this project was the research work of our partner in Norway, Sintef. And they were working on an open loop heat pump that was implemented in a biosludge dryer that is located in Scanship in Drammen. And here you see the operation experience that we have gathered with the closed loop heat pumps. In this diagram, you see the temperature lift on the x-axis and the COP on the y-axis. Here we have the heating COP, which is the heat that is delivered by the heat pump and the electricity that is consumed. And with the 2 demonstrators, we have really tested the whole range of what's possible with these plants. So we have successfully collected about 8,000 hours of operation with the 2 demonstrators. And this has proven that also the component development that was necessary for these heat pumps was very successful. So the compressors, the lubricants, and the refrigerant that was used. In the diagram, we have crosses for the values that were gained at the Wienerberger installation and circles for the values from Agrana. And the color code indicates the heat supply temperature, starting from dark blue, which is 105 degrees C, over light blue, green, orange, red to dark red, which is 160. And I want to show you 3 stages and 3 points of operation in more detail. Starting with the highest temperature, at 160 degrees, we had a COP of 2.2. And when we compare this operation of the heat pump with a natural gas burner that is delivering the same amount of heat, we have a CO2 emission reduction by 62%. We have calculated these values using the Austrian electricity mix, which is renewable, but it's not 100% green electricity for the time being. And this also, another important value is also the final energy reduction, because this basically translates in energy cost savings. And this was also in the range of 60%. And
When we go to lower temperature lifts, so this is basically lower supply temperatures when we keep the source temperature constant, we have at a supply temperature of 120 degrees C a COP of 5, which is very attractive. And then we have also very high CO2 emission reductions and final energy reductions in the range of about 80%. So this demonstration of the high temperature heat pump was very successful, and it also showed the benefits for industrial companies to integrate a heat pump in their process and to make use of the waste heat that is otherwise just went into the environment. We also work on steam generation at AIT, because steam is a major energy carrier in industry, and it has a very interesting multiplication potential because we can integrate those heat pumps that are able to generate steam into existing steam networks, which makes it easier for the end user to switch the energy supply to a renewable source. We have several options to produce steam with a heat pump. It can be either done in the condenser, as we have seen it before in the presentation of Siemens. This is the thermodynamic optimal solution, because then we have the least number of energy transfer steps. So we use the condenser to condense the refrigerant and evaporate the water that is then used as steam in the process. But steam can also be generated in a flash tank. So after producing the high temperature with the heat pump. So this is also interesting for retrofitting existing water-to-water heat pumps into a steam generating unit. And we can combine it with an MVR system. And I will show you examples for those activities. The first example is the Bamboo project. It's another Horizon 2020 project where we did a lot of work on steam generation with a heat pump and a flash tank. And on this photograph, you see the installation that was set up in the lab of EDF in France. On the left, there's the heat pump. It's a water-to-water heat pump operated on a synthetic refrigerant, R1336 MZZZ, that produces pressurized water. And that pressurized water is then used in a flash tank unit that was especially designed for this purpose. And there steam is produced by reducing the pressure of the pressurized water. So part of the water is then evaporated, and the steam can be used for further application. And with this installation, we have done many different tests also to learn about the behavior and the control parameters that we have in this coupled system. And this diagram, you see the steam mass flow on the x-axis and the COP on the y-axis. It's again the heating COP with the amount of heat that is delivered divided by the electricity that is consumed. And the colors show the pressure of the steam that was produced, which is basically an indication of the heat supply temperature. So it is saturated steam. And the blue dots represent 2 bars, which is 120 degrees C. And the yellow dots are 5 bars, which is 150 degrees C. So this was also a very successful demonstration project. And it illustrates how heat pumps that produce hot water can be retrofitted into steam generating units. And finally, I'd like to introduce you our newest project. It's called AHEAD, Advanced Heat Pump Demonstrator. We have just kicked it off, so we started in December, so it's rather new. And there we work on steam production at 11 bar and 184 degrees C based on heat pumps and MVR systems. This heat pump will be integrated at a production site of Takeda, a pharmaceutical company with several production sites in Vienna. And this heat pump will be a major item in their energy supply system. So with steam produced by the heat pump, they can reduce their CO2 emissions by 90%, and they can produce totally CO2-free for about 7 months a year. In this project, we will design, set up, and also monitor and optimize this heat pump system for more than 4,000 hours. That's the scientific monitoring. Of course, operation will then go on. And here you see how this system looks in theory and what we are going to build in the future. So in blue on the left, we have the existing system. They have a central chiller unit where they produce cold utilities or cold water for the production at a temperature of 6 degrees. And the central chiller has waste heat. So it was equipped with a heat pump. And that heat pump, it's an ammonia heat pump. It produces water for heating purposes at 70. And we use this water at 70 as the heat source for the AHEAD system, which is a combination of a steam generating heat pump. This heat pump is provided by SPH, Sustainable Process Heat, and they will use butane as a refrigerant. in their heat pump, and the heat pump is based on piston compressor technology. So the heat pump will produce the steam from the water, and then we will add steam compression steps to reach the 11 bar and 184 degrees. The installation will have a heating capacity of 1.7 megawatt, so it's a really big production facility. And with this setup, we can connect the heat and the cold supply based on a cascaded system of heat pumps that is based on natural refrigerants only. And we will operate this installation with renewable electricity. So this is how this CO2-free production can be achieved. This project is part of an Austrian energy model region that's called NEFI. This is new energy for industry. And as a part of this model region, we demonstrate different efficient technologies that are needed to transform the industry into carbon neutral production. And for the end of my presentation, I have brought you another result of NEFI that has been done by my colleagues at EAT and colleagues from University of Leoben. And they work on decarbonization scenarios for the Austrian industry. So basically, they have defined different scenarios how we can reach zero emissions by 2050. So there were two approaches to get to this result. For the zero emission pathway, this is shown on the right, it was a backcasting approach. So starting from the desired result at 2050, defining the measures that need to be taken to reach that result. The second scenario that's shown on the right, on the left, that's called Pathway of Industry. And this was created together with representatives from industry in Austria on the different measures that are planning to take and extrapolating them to 2050. So we find different important technology levers in these scenarios. And for today's webinar, the most important one is the one that's listed here in the third place. It's electrification for heat pumps for low temperature applications. So we really find heat recovery with heat pumps in all industrial sectors. And you can see it also reflected in the results of the total energy demand that is shown in these two diagrams. So the most important section in the bars is the dark blue. That's the electricity consumption. And the diagrams, there's a laser pointer. Great. So this is the dark blue section. That's 2017, 2023. And here we have 2050. And when we compare these levels, we see a double in the electricity consumption, and that's not only, but also based on the use of heat pumps. In this scenario work, they also listed several measures that are needed for the future. So one of them is we need further pilot plans to demonstrate new technology in industry, also to gain trust and experience with this during this transformation. And if you're interested in the whole study, I've also put the link here that you have all the information, how it was calculated and what's the background story on it. So, with that, I'm at the end of my presentation. A very short summary, very generic summary for heat pumps, and I think that goes for all the four presentations that we had today. Heat pumps are a future-proof technology for process heat supply, because with this technology we can reduce the CO2 emissions and increase energy efficiency, which is definitely something that we need to reach decarbonization in the future. And most important, we can electrify heat supply and allow for waste heat recovery, which is also very important to keep the industrial sites operating in the places where they are. And we've also seen in a couple of studies that integration is most decisive for efficient solutions. It's a very active field. There's a lot of development going on in different research projects, but also among manufacturers and heat pump suppliers. So we see more and more products entering the market. It's a trend towards high temperature and, of course, steam generation. And demonstration projects, as they were shown today, are an important item to establish these new technologies. And I look forward to hear more about these different demonstration activities. And I'm also happy to present more information on our activities in the future. Thank you.
Okay, thank you very much, Veronica, for your presentation. I see that everyone's clapping now, so I guess the audience is quite happy about it. Just gonna move to the slide so everyone can see your contact details. So Well, I want to thank all the speakers for the presentations. I think now it has the time to arrive to ask some questions. So I have some questions for you myself here. I will start with you, Veronica, since I think you're still connected, you're still unmuted. So I wanted to ask you, what would you say is important when integrating a heat pump into an industrial process?
Yeah, first of all, we need to do an inventory of what's possible in this process. So usually when we start a discussion on heat pumps with a company, they have a waste heat source in mind and they have an application in mind. But if we dig deeper, we find other sources that are also interesting. And there also might be changes coming up in the future relating to the process. So temperatures might be lowered, equipment might be more efficient, and this will have an impact on the waste heat that is available. So first of all, it's important to consider all these boundary conditions and then select the right spot to put the heat pump in.
Lovely, thank you. Now, I want to ask a question to Andrew this time. Let's switch a bit the order. So I wanted to ask you if you could elaborate on how the Spirit project overcomes the non-technical barriers to widespread the heat pump uptake.
Yeah, no problems, Arena. I think this is a big aspect of the Spirit project, and what comes to mind actually is that we have a task where we want to identify policy, regulatory, and other barriers which prevent the uptake of this technology. I think EHPA is indeed leading this task, and in the first instance, I think in that as part of that task, we look to existing policy and regulations and how they could hinder the uptake of industrial heat pumps. I also mentioned before in my at the small question at the end of my discussion is that we, in terms of other non-technical barriers, we try to have stakeholder engagement along all areas of the value chain to sort of get perception of the technology from a larger audience. I also think as part of Spirit, on this non-technical aspect, we're looking towards the development of a competency framework. And well, what does this competency framework mean? If you consider that what I mentioned before from this IEA study that we need to roll out 500 megawatts of industrial heat pumps over the coming years, I think that that means that we don't just need to have the supplies in place, but we need to have all aspects of the downstream processing. So we need to have installers, people that can supply this. We also need to have knowledge with consultants available to, how can this technology be integrated in the process? A little bit along the lines of what Veronica just the process that Veronica just outlined. So hopefully we can develop this, what this competency framework should look like for the future, and the first steps can be taken by the manufacturers in developing this or rolling this out. And maybe just as a last point, something that comes to mind on knowledge dissemination, overcoming the non-technical barriers. Well, I think it's important that we have knowledge in the wider community about the benefits of this technology. And as part of the Spirit project, we also plan to have a summer school. And that's a really strong ambition that we want to have, so that we can have, for instance, master students, PhDs, postdocs that can, let's say, learn more about this technology and take those learnings which we generated in the project into their employers, and spread the word, I think.
Thank you, Andrew. I really like the summer school. I think we have discussed it internally as well in EHP. I think it's a great thing to bring it directly.
I think the nice thing about that we have this project that we can get this summer school started, and of course it would be a nice ambition to have that this Spirit summer school continues beyond the realms of the project. So that's something that we need to see, I think.
Yes. Well, step by step, the project is started quite recently. So from project to project, now I want to ask Maider a question. You presented today, 4 demo sites, and I wanted to ask you, when do you think you will start having more accurate results on these demo sites?
Yeah, it's what you have just said. The project, both projects, Spirit and Push to Heat, have recently started. So we are still working on the energy first initial energy assessment and so on. So let me think. Well, we have 3 demo sites that will be implemented, designed and implemented from scratch. The 4th one, as you have seen, will be different. So, and each of these 3 demo sites, well, will have different development, of course, depending on many issues, on-site implementation, and depending on the production and so on. But in principle, the idea is that the implementation will be done after summer of next year, more or less. Yeah, so by October, well, by the end of next year, we should have the demo sites implemented. Then we'll have a period of for commissioning and the first tests and to have everything well commissioned and so on. And then the idea is to have at least 1 year of full monitoring, having all the demo sites in operation and to do all the data analysis and the measuring results from measured data and so on. So until next year, we won't have these demo sites implemented. But of course, I mean, from the project, the idea is to well, do more dissemination to show all the final design of the demo site and so on as well, to spread out all this information, and then more accurate results on measuring data will come.
Of course, thank you, Maiden. Yeah, of course, during the course of the project, that it should last around 4 years, maybe more, we don't know. And there will be several dissemination events. And of course, I want to also remind you all that both Spirit and Push to Heat will have newsletters coming out this April. So if you're interested, you can just subscribe to them. We will, as I said, we will reshare the slides with you all in the next days. So there you can find all the information to subscribe to those newsletters. And of course, you have all the contact details of the speakers should you have more questions that can be solved today. And also you can send the questions to me and I will redirect them to the person that should answer them. And now I have a question for you, Jochen. You're not off the hook yet. I wanted to ask you, does Siemens Energy supply the combination of heat pump and steam compressor, or are you just supplying the heat pump?
No, let's say we are let's say willing and able to supply both. If and we can do the analysis like, is a high temperature heat pump alone, let's say, is the best solution for the customer, or is it a combination? And if it is a combination, then we can supply both, because let's say there is some let's say non too trivial interaction between the high temperature heat pump and the steam compressor, for instance, with respect to dynamics. So we think it's a good thing that it is, let's say, coming from one supplier.
Okay, thank you. And now I want to ask you a question to you all. I think it was one of the questions that were in the chat. I wanted to ask you all, please, everyone provide their answer, whether you want. That I wanted to ask you whether if you see industrial heat pumps as a game changer for any sector, or more of a type of incremental improvement? And do you think this decarbonization via heat pumps can change the current landscape? And I don't know, Jochen, since you just spoke, if you want to start answering that question.
Well, I think you mentioned in when you introduced me as a person that I was doing something like, let's say, energy system consulting for some years before I took over the responsibility for the high temperature heat pump. So we went to specific customer sites like an industrial paper mill or a chemical site or some local utility, and we developed let's say, decarbonization pathways here. And let's say I learned in this phase, yeah, that heat pumps and high temperature heat pumps, let's say, are always part of a techno-economic optimal solution. Yeah, and let's say as a person, yeah, that's why I thought that taking the responsibility for high temperature heat pump was a nice offering, so I accepted. Yeah. So I think it's really it's a very, very important technology for the future. And well, game changer is sounds let's say, like a very big word. Yeah, to my mind, I would phrase it like this: it's always part of the techno-economically optimal solution. Yeah? And it will be always a combination. Yeah, like there's no silver bullet, so it will be most probably combined with like an e-heater and a thermal energy storage, for instance. Yeah, if it is about hot water. Yeah.
Great. Veronica, for instance, what's your take on that question?
Yeah, I'd like to support that, what Jochen said. So, well, we do research on high temperature heat pumps, but it's not only about the technology, but also the right integration. So it's really about the system where it is used in the end, and those systems are sometimes very different. So they are in a different status, and they also have different decarbonization goals and also different speeds to do this transformation. So this is something that has to be taken in mind. I definitely see the heat pump as a part of a system that can really make waste heat that should not be there in the first place. But if it's there, it can be reused. So it makes waste heat more valuable. And the very interesting question for the future will not only be the availability of waste heat, but also the integration of a heat pump directly into the process. So whenever we have heating and cooling, this is a sign for heat pump application. So we will move away from this traditional approach of waste heat recovery to heat pumps that are a central part of the process itself. And then we get to even more efficient installation when you do it that way.
Thank you very much, Veronica. Maybe Andrew, can we hear your take?
Yeah, I'm 100% behind. I'm fully converted as a heat pump as a game-changing technology. So I'll put that out there. And I think that if we look at the structure of the existing energy system in industry, I mean, I mentioned before, it's based around these cheap and readily available fossil fuel sources, and because there's this historic cheap and readily available fuel sources that I mentioned, what that means is that, or at least my perception is that industry has been looking for low-hanging fruits, so small efficiency improvements for their processes. And now, because that's no longer the case, they're forced to make step changes. And then heat pumps are the technology which can make that step change for the process. So I definitely think it's a game changer in increasing the competitiveness of industrial processes and the European industry as a whole.
Mm-hmm. Thank you, Andrew. And either. What is your take on that?
Yeah, well, fully agree with previous comments. I would like to make or to highlight a little bit more the point on the integration. I think, well, it has already mentioned more or less, but it's I think it's very important. I mean, this is not just about the technology. Of course, as better is the efficiencies of the technology, of course, better than the technical or economic figures. But I think a key issue here is the integration, because I mean, it's the story is very different from just producing steam with boilers or producing steam, for example, steam or whatever it is with heat pumps. So for a boiler, it's the same, if more or less the same if we are producing at 14 bars, 8 bars, or whatever, but for the heat pump, it's completely different. So I think there is a lot to do also on the industry side, end user side, to see how this can be best integrated in the industrial processes, and this then it's directly impacting the final figures, so the system economic and the energy figures or whatever. And also another point, we haven't talked about flexibility, but I think heat pumps, one of the advantage or another feature that is linked to heat pumps is also the increase that they can increase the system flexibility together to thermal energy storages, for example. So this could help also, I mean, could bring more benefits than just the ones directly related to the technology, energy efficiency or whatever. So because it's a power to heat system, yeah. So we are taking electricity, we are converting it into heat. So together to thermal energy storage, we can also take more benefits from increasing the flexibility and playing a little with this, taking advantage of best electricity prices, green electricity from PV, for example, and so on.
Mm-hmm. Yeah, thank you very much, Maida. I think it's important to actually highlight the flexibility that heat pumps can provide combined with thermal energy storage. Now, I want to ask you a question. This is a bit like, I would say it's creative, but not really creative. I wanted to ask you if you could summarize what you have presented to us today in one sentence or one slogan, what would you say? So, for instance, Maida, since you were speaking, if you have to present like, oh, I presented push to heat today, how do I summarize what I presented today in one sentence? I know it's difficult, huh? But
yes, a difficult one. Well, there's so much to say. I mean, it's a difficult one,
No, yeah, but you can say, I say one sentence and I know it's too much, but like you can say, let's say one paragraph.
Yeah, I would say we have the opportunity for high temperature heat pumps is there. Technology is there. So let's go beyond these existing barriers nowadays, because now is the moment to do it and to push the market potential, as it's the title of the Push to Heat project.
Lovely. Like the others, don't be scared of me. Like I'm also asking you the same question. It doesn't have to be a sentence. It can be like, as I said, like some sentences, like summarizing what you mentioned today, or like what you want the audience to have as a takeaway from the session. So I don't know, Jochen, if you want.
Yeah, I think it's very simple. Yeah, it's let's make tomorrow different today. Yeah, we are ready to start.
Lovely. I like that one. It's a great slogan. Andrew?
Not invented by me, it's by our communication department.
Very glad of that slogan from your communication department. I think it's a very nice one. So, Andrew, if you want.
Yeah, I think I'd take it back to the Spirit project and say that we have this nice project where we have strong ambitions to establish heat pump technology as the reference low carbon technology for industry. So that's my main take home message for the audience. And we do that through the development of the technology, which is demonstrated in industrial sites, and also supporting developments that we mentioned in the presentation.
Mm-hmm. Thank you, Andrew. And then finally, Veronica.
So that's difficult to do this, to add to these fabulous slogans that we have before. But I'd like to emphasize that demonstration projects are key to establish new technologies in industries. And this is what we will do also in the future to continue to work on high temperature heat pumps for interesting industrial applications.
Okay, that's lovely. So thank you, speakers, for this for these answers to my very strange, I would say, question, but I think it might be of relevance to the audience. I want to remind all the audience that, of course, if we didn't address your questions today, you will be able to ask, as I mentioned, like a bit before, we will be able to answer the speakers directly, because I will ask the speakers directly, because we will share the presentations and the contact details are there. Of course, if you, for some reason, don't want to address directly the speaker because you want to check with me or my colleague Sonia that is behind the scenes today, no problem. You can send the email to me and I can just redirect it to the right person. I want to take this opportunity again, since this event was to present, actually, of course, to address heading to the decarbonization in the industrial sector with the high temperature heat pumps, but it's also the first event that we have organized for Push to Heat and Spirit in collaboration. I wanted to ask you all to check our websites, follow us on LinkedIn, follow us on Twitter, send us emails. We will be super glad to keep you updated. Again, you can also subscribe to the newsletters that will be coming up in April. And of course, we will organize probably way more dissemination events, together or separate, but I guess we will have several collaborations, because as I think you could see during the event, that there were many points in common between the projects. Then, of course, I have to mention this. This event was organized by EHPA. So, of course, if you would like to know more about EHPA and other very interesting events we organize, I recommend you that you scan that QR code and then you follow us on Twitter, LinkedIn, YouTube. We have also a wonderful newsletter. So, I think it could be of interest to you as well. And now I want to actually thank you, all the speakers, for being here today and for your very interesting presentations. I repeat again, we will make available the slides. We will make available the recording very, very soon. Just be a bit more patient. We need some days to manage this. I want to also thank my colleague Sonia, that she's behind the scenes today, but she's here supporting us with the webinar. And of course, I want to thank all the audience that came here today. There was lots of interaction, which makes me very happy. So yeah, thanks for coming today. It was great being here with you. I wish you all a very healthy week, because as you can hear in my voice, I'm a bit sick. But thank you very much, and I hope to see you in our next event. So have a lovely day.